What is an atom?
Atoms are among the most basic building blocks, making up all matter. The word atom derives from the Greek word atomus, which means that which cannot be split. The existence of atoms, or a fundamental, indivisible unit of matter, was proposed long before modern chemistry and physics came about. It turns out that atoms are actually made up of even smaller particles. But the atom is the smallest unit of matter that defines an element. The smaller particles that make up an atom are positively charged protons, charge-neutral neutrons, and negatively charged particles called electrons.
How is radiation used in medicine?
We should begin by pointing out the distinction between radiation used in nuclear medicine / radiopharmaceuticals, more akin to the other topics of this chapter, and electromagnetic radiation, light of different wavelengths. Nuclear medicine is the branch of medicine most closely tied to the concepts of nuclear chemistry discussed in this chapter. Diagnosis via nuclear medicine typically involves the injection of a radiopharmaceutical into the body, and the radiation released by this drug can then be monitored to gain information about organ function, blood flow, the location of a tumor, or to locate a fractured bone. In some cases, the use of nuclear medicine can allow for earlier diagnosis than with other imaging techniques. In terms of using electromagnetic radiation for medical applications, perhaps one of the first treatments that come to mind is radiation therapy, which is used to fight against a broad range of cancers. This involves using focused electromagnetic radiation to damage the DNA in the tissue of a tumor while hopefully not causing too much damage to the surrounding healthy tissue. The goal is to damage the DNA of cancerous cells so that they are unable to reproduce, hopefully killing the tumor with time. Beams of radiation are focused onto the tumor from different angles to minimize the effect on any one area of healthy tissue. Rays and CT scans are two commonly used, non-invasive medical techniques that make use of electromagnetic radiation to take pictures of what's going on inside the human body. It should be noted that prolonged exposure to the X-rays used in these procedures can be harmful and are capable of causing cancer themselves over long periods of time.
How can I show my friends a magic trick using pepper?
Chemistry principles encountered in this experiment: polarity surface tension materials. You'll need a shaker or small packet of black pepper dishwashing soap, a few drops, bowl water, a bowl full. The procedure: begin by filling the bowl with water. Then pour black pepper onto the water to form a thin layer of pepper across its surface. As a control experiment, Try dipping your finger below the surface of the water. Nothing too interesting should happen at this time. Now rub a small amount of dishwashing soap on your finger and dip it in the water again. This time, you should see the pepper move away from your finger and toward the edges of the bowl. The nonpolar soap molecules don't want to dissolve beneath the surface of the water, and thus they spread across the surface of the water quickly, which lowers its surface tension. Whereas water typically bulges a bit above its surface due to its relatively high surface tension. The water spreads out when its surface tension is lowered. This causes the water to spread out as the soap moves over it, and the pepper is carried away from your finger in the process. Now that you understand the basics of this trick, you can perform it for your friends. Ask a friend to dip their finger in the water and to try to concentrate on trying to make the pepper move away from their finger. When they cannot make it happen, you can step in and use your already soapy finger to easily move the pepper away.
What affects melting and boiling points of chemical compounds?
Intermolecular, between molecules, forces govern the melting point of a chemical substance. These include van der Waals interactions, dipole-dipole interactions, hydrogen bonding, and, in the case of ionic compounds or ionic solutions, ionic bonds or Coulombic interactions. The stronger the intermolecular forces between the molecules in a solid, the harder they will be to melt, so stronger intermolecular forces lead to higher melting points. The same is true with boiling points. Stronger intermolecular forces make the molecules harder to separate, leading to higher boiling points. For solids, the shape of a molecule can also affect its ability to pack into an ordered lattice. Having a shape that allows a well-ordered lattice to form will tend to stabilize the solid phase of a compound, leading to a higher melting point. The shape of a molecule can also affect the boiling point of a compound. In liquids that are able to form hydrogen bonds, the location of the hydrogen bond donor or acceptor can affect its spatial availability to serve as a donor or acceptor. In organic liquids, where van der Waals interactions are important, molecules with larger surface areas will have stronger van der Waals interactions, leading to a higher boiling point.
What is smoke?
Smoke is a cloud of particles given off by a material that undergoes combustion. Its chemical composition will vary depending on what material is being burned. Smoke may consist of hydrocarbons, haloalkanes, hydrogen fluoride, hydrogen chloride, and a variety of sulfur-containing compounds, among others. These compounds can vary widely in their toxicity. So the severity of the health hazards associated with the smoke from a fire will depend on what is being burned.
What is the composition of air?
Earth's atmosphere is made up of 78% nitrogen, N2, and 21% oxygen, O2, if you ignore water vapor, which shifts too much to include in averages for the entire planet. The last 1% is made up of mostly argon, Ar, followed by carbon dioxide, CO2, and other trace gases.
What is gravimetric analysis?
Gravimetric analysis refers to any method for quantifying the amount of an analyte based on mass. For analytes dissolved in a solution, this may require first reacting the analyte with another species to cause it to precipitate out of the solution. The solid product can then be filtered and weighed, and the mass of the analyte initially dissolved in the solution can be determined. Other situations may require different methods of preparing the analyte in an appropriate form for weighing. But the general idea is always that the composition of the weighed species is known. So it's possible to figure out the mass of the analyte originally present.
What is a voltage?
A voltage, or potential difference, is the difference in electric potential energy between 2 points. The voltage describes the amount of work that would need to be done per unit charge, to move a charged object between the two positions. A voltage may be present due to a static electric field, to electric current flowing through a magnetic field, or due to magnetic fields that change over time.
What is a sigma bond?
A chemical bond involving direct overlap between orbitals on adjacent atoms. Sigma bonds are symmetric with respect to rotation around the bond axis.
What is an isotope?
Atoms of the same element, same number of protons, with different number of neutrons.
Why did Wilhelm Ostwald, Germany, win the Nobel Prize for Chemistry?
For his work on catalysis and for his investigations into the fundamental principles governing chemical equilibria and rates of reaction. Ostwald performed many experiments surrounding the strengths of acids and bases and was the first to carefully explore how reaction rates are affected by acid/base catalysis. He was actually the first to coin the term catalysis in the context of chemistry. And his definition of catalysis is still very much the same as the one used today. Ostwald's work corroborated earlier studies into acid/base chemistry by Arrhenius, and his measurement of chemical reaction rates under various acidic and basic conditions placed the understanding of Brønsted-Lowry acids and bases on a more sound footing. Ostwald also expanded the scope of his study beyond acid/base catalysis, and his work led to the understanding of chemical reaction rates as we know them today. He showed that chemical reaction rates Y did and the factors that influenced them Y did were quantitatively measurable parameters.
What is a ground state?
Lowest energy state for an atom or molecule.
What is mass?
The resistance of an object to acceleration, commonly used interchangeably with weight, though the latter depends on gravity while the former does not.
What is the valence shell of electrons?
Electrons fill up orbitals in shells. The innermost shell consists of just one s-type orbital and can hold just 2 electrons. The next shell consists of one s-type and 3 type orbitals, and can hold 8 electrons. Higher shells consist of more and more orbitals and can thus hold more and more electrons. The valence shell of electrons is the highest occupied, or partially occupied, set of orbitals.
How does pressure affect the rate of a chemical reaction in the gas phase?
In a gas phase chemical reaction, the pressure, or partial pressure, of a chemical species is directly related to its concentration. In just the same way we could write rate equations for solution phase reactions involving a constant multiplied by the concentrations of species, we can write rate equations for gas phase reactions that involve a constant multiplied by the partial pressures of species in the gas phase. So just like in a solution phase reaction, increasing the pressure of a reactant in the gas phase will increase the rate at which products are formed.
What determines whether a particular type of nucleus can be monitored by NMR spectroscopy?
Similar to electrons, nuclei can have a net spin, or spin-angular momentum. NMR spectroscopy can be used to study any nucleus that has a non-zero spin-angular momentum. Some common nuclei that chemists study by NMR are 1H, 2H, deuterium, 13C, 11B, 15N, 19F, and 31P.
What is a s orbital?
An atomic orbital with an angular momentum quantum number of 0, shaped like a sphere.
What's the difference between baking soda and baking powder?
Baking powder is a mixture of three things: baking soda, an acid, and a filler, usually cornstarch. The acid takes the place of the buttermilk or lemon juice in a recipe, see the previous question. To release CO2 from NaHCO3. The starch is in the mix to keep the two components from reacting before it gets into your cookies and to keep everything dry.
Why did Paul D. Boyer, United States, and John E. Walker, United Kingdom, win the Nobel Prize for Chemistry?
For their elucidation of the enzymatic mechanism underlying the synthesis of adenosine triphosphate, ATP, and Jens C. Skou, Denmark, for the first discovery of an ion-transporting enzyme, Na+, K+AT-PASE. Boyer and Walker shared half of this prize for their work to understand how ATP synthase, an enzyme, catalyzes the formation of ATP. This information bears a crucial relationship to understanding how energy is stored, transferred, and used in cells. Skou received the other half of the prize for his work to discover the first ion-transporting enzyme, which is responsible for keeping the balance of sodium and potassium concentrations in cells.
What is a chemical bond?
A chemical bond is an attractive interaction that binds atoms together through a sharing of electron density. The simplest bonding arrangement involves just two electrons shared between nuclei such that each effectively has a stable octet of 8 valence electrons, or just 2 in the case of HH. When two atoms are sharing a total of 2 electrons between them, the atoms are referred to as singly bonded to each other. Bonds are what hold atoms together in molecules, and they are usually not easily broken. The arrangement of atoms in a molecule determines the identity of a chemical compound. The making or breaking of bonds is a chemical reaction, which converts one chemical compound into another.
Why did Robert Bruce Merrifield, United States, win the Nobel Prize for Chemistry?
For his development of methodology for chemical synthesis on a solid matrix. Merrifield developed a simple and very clever way of synthesizing peptides or chains of nucleic acids. The method involves binding the first of the chain of, let's say, amino acids to a polymer. The subsequent residues can then be added synthetically. And this approach turns out to be faster and yield larger quantities of the desired final product than earlier methods.
What is a carbocation and what is a carbanion?
A carbocation is a positively charged compound in which a carbon atom takes on a significant fraction of the positive charge. The definition for a carbanion is probably easy to guess. Then it's a negatively charged compound in which a carbon atom bears a significant fraction of the negative charge.
How does a pregnancy test work?
A pregnancy test works by detecting a hormone called human chorionic gonadotropin, HCG, that is produced in the placenta after fertilization. The HCG hormone will be present in the blood and urine about a week after conception. And it's detected by an indicator molecule on the pregnancy test that changes color upon binding to HCG. The tests you can buy in the store are actually pretty similar to those used at a doctor's office. Both are based on HCG binding to a chemical indicator that changes color. The main difference is that the doctor's office has technicians who are more familiar with using the tests. So there's less chance of a mistake with using or interpreting the test.
What is flame ionization detection?
Flame ionization detection, FID, is a method of detecting organic analytes in gas phase chromatography experiments. A very hot flame is used to burn the analytes emerging from the chromatography instrument, which produces positively charged ions. These ions are then attracted to a negatively charged electrode, which detects them by generating an amount of current proportional to the number of positively charged carbon atoms reaching the electrode. FID can be particularly useful due to the fact that it detects organic analytes without any interference from a wide variety of other gases, which can be present in the sample or in the carrier gas used in the gas chromatograph. There are some downsides to FID, one of which is that the sample is destroyed as it is analyzed.
Will you contract poison ivy if you come into contact with a person who has it?
Poison ivy is caused via an oil called urushiol, found on the leaves of poison ivy plants. The only way to contract poison ivy is to come into contact with this oil. Thus, if a person who has poison ivy still has some of the oil from the plant present on their skin, they could spread that oil to another person. In most cases, though, by the time a person has a rash, the oil will have been washed away. To be clear, the blisters on a person's skin who is suffering from a poison ivy rash do not themselves have the potential to spread poison ivy to other people.
What properties influence solubility?
The most significant properties are intermolecular forces and temperature. If there are favorable interactions between the solute and the solvent, solubility will be higher. This is actually a balance of the interactions of the solute with the solvent and the stability of the solute in the solid phase. Temperature also influences solubility, and for most substances, solubility increases as the temperature of the solvent rises.
What is gene therapy?
Gene therapy is a method of medical treatment that tries to correct defective or disease-causing genes. There are a few ways that this may be attempted, all of which are centered around getting a normal functional copy of the gene inserted into the genome. Some methods involve repairing the mutated gene, while others involve just adding a working copy of the gene into a non-specific location in the genome.
How fast is Earth moving through space?
When taking into account the motion of the Milky Way galaxy, the fact that our solar system rotates within this galaxy, and the motion of the Earth within our solar system, it is estimated that the Earth is moving at about 500 kilometers per second. Of course, since everything around us is moving at the same rate, we don't tend to notice this.
What is green chemistry?
Green chemistry is the practice of designing chemical products with the goal of minimizing the amount of hazardous waste that is generated in the process. This is frequently a complex issue since one needs to consider not just the synthesis of the chemical product but also the sources from which the reagents are obtained, the manufacture of the product, and the end of the product's life cycle. In a seminal book on the topic, Paul Anastas and John Warner defined green chemistry as the utilization of a set of principles that reduces or eliminates the use or generation of hazardous substances in the design, manufacture, and application of chemical products.
What is isobaric?
With constant pressure.
How are glucose levels regulated?
In humans, the amount of glucose in the blood at any given time is regulated very carefully. If your blood glucose level is too high, your body releases a chemical called insulin into the bloodstream, signaling that it's time to convert some of the extra glucose floating around into glycogen. Similarly, if your blood glucose level gets too low, your body releases a chemical called glucagon into the bloodstream, telling your body to start breaking down that glycogen to release more glucose into the blood.
What is precision?
The extent to which a measurement is repeatable. Note that this is distinct from accuracy.
What is a prion disease?
Prions are misfolded forms of proteins that behave in an infectious manner. They do so by causing other proteins they encounter to misfold as well. A prion disease is a disease that results from this misfolding. Some examples of prion diseases include mad cow disease, scrappy, and Creutzfeldt-Jakob disease. In mammals, all known prion diseases are actually caused by the same prion protein. Known as PRP, the abbreviation actually stands for prion protein.
What is astrobiology?
Astrobiology is a branch of science concerned with looking for signs of life. Basically, anywhere other than on planet Earth. This isn't really the search for space aliens hanging out in close vicinity to our own planet. But rather astrobiology is focused on looking for any evidence for the current or prior existence of even the smallest, microbial, life forms elsewhere in space.
What kind of fuel is used to power a spacecraft?
The Space Shuttle Endeavour, which made its final space voyage in September of 2012, used primarily hydrogen, oxygen, hydrazine, N2H4, monomethylhydrazine, CN2H6, and nitrogen tetroxide, N2O4, as fuels. As it took off for a space voyage, the spacecraft would carry 958 gallons of these fuels with a total weight of roughly 1.6 million pounds.
What is snake venom?
Most venoms are mixtures of dozens of compounds. And the active toxic ingredients are proteins that wreak havoc on the recipient in a variety of ways. While the exact enzymes vary from species to species, and even geographically within a species. Many snake venoms contain some sort of neurotoxins which block signals sent through your nervous system, leading to numbness or even paralysis.
How does a pressure cooker speed up cooking?
If the lower atmospheric pressure in Denver increased cooking times by lowering the boiling point of water. What if we could increase the boiling point of water? That's exactly what a pressure cooker does. Pressure cookers are sealed such that once you start to heat water, the pressure inside the vessel increases. This increase in pressure drives up the boiling point of water because every water molecule that tries to make the transition from water to liquid has a greater force pushing against it. By increasing the pressure inside the pot, pressure cookers can get the boiling point of water up to about 120 degrees Celsius 250 degrees Fahrenheit. With water boiling at a higher temperature, your food cooks faster.
Why did Carrie B. Mullis, United States, win the Nobel Prize for Chemistry?
For contributions to the developments of methods within DNA-based chemistry for his invention of the polymerase chain reaction. PCR, method, and Michael Smith, Canada. For contributions to the developments of methods within DNA-based chemistry for his fundamental contributions to the establishment of oligonucleotide-based site-directed mutagenesis and its development for protein studies. Mullis was awarded the prize for developing a widely used laboratory method called the polymerase chain reaction, PCR, method. PCR allows the use of relatively simple lab equipment to generate millions of copies of a sample of DNA in the time span of only a few hours. This has found diverse applications in a large number of laboratories. It can be used, for example, to generate copies of DNA from fossils of organisms that are long since extinct. Smith shared the prize with Mullis for his work manipulating the genetic code. In cells, proteins are produced based on sequences of nucleotides contained within the organism's DNA. These sequences dictate the sequences of amino acids that will be incorporated into a protein. Smith developed a method to selectively manipulate DNA to alter the amino acid sequences of the proteins that are produced.
What does a preservative do?
Preservatives keep food fresh by slowing the growth of mold and bacteria, antimicrobial preservatives. Preventing oxidation, antioxidants. Or slowing enzymes from continuing the ripening process after a fruit or vegetable was picked or cut.
What is radioactive?
Emission of radiation or particles.
What is a valence shell?
The highest partially occupied shell of electrons in an atom.
What is osmosis?
Osmosis is the movement of solvent molecules in a solution to establish an equal concentration of solute throughout the solution. Solvent molecules move from areas of low solute concentration to areas of high solute concentration, which tends to remove any gradient in solute concentration.
What is a carbon-hydrogen bond activation reaction?
Carbon-hydrogen activation reactions are very much what the name would imply. They break typically unreactive carbon-hydrogen bonds. Considering the prevalence of carbon-hydrogen bonds in organic compounds, this is another extremely important type of reaction to be able to carry out both effectively and with selectivity. Successful examples of carbon-hydrogen bond activation reactions have only come about relatively recently, with the first genuine example reported ca. 1965, and organometallic reagents have played a key role in the development of carbon-hydrogen bond reactions.
How do our brains tell time?
Until very recently, scientists presumed, and it's not clear that there were many experiments to support this, that our brain had a stopwatch of sorts built into its machinery. By stopwatch, scientists meant some biological system that created some signal at regular intervals. If this were true, we would be equally good at estimating short and long periods of time. But that's totally not the case. Humans are pretty awful at guessing how long extended periods of time are. Instead, Dean Buonomano at UCLA proposed in 2007 that our brains tell time in a different way. To steal his analogy, imagine a rock being tossed into a lake, which creates a series of ripples in the surface of the water. If you were to throw a second rock in, the ripples from the two rocks would interact with each other. The pattern of this interaction depends on the time between the two rocks hitting the lake. The firing of neurons, the rocks hitting the lake, create these unique patterns in their signals, and neurons can use the different patterns of signals interacting to tell time between events. The wonderful piece of this theory is that it explains why we're good at telling time over short durations, but not long ones. Over a long time, the ripples in the water just fade away.
How do photovoltaics convert light into energy?
Photovoltaic cells are the materials responsible for converting the energy in photons of light from the sun into energy that can be stored or used. Individual cells usually range in size from areas of roughly 1 square inch to 1 square foot. And thousands of cells can be used simultaneously to harvest large amounts of energy. When photons of light strike the photovoltaic material, they excite electrons from a piece of silicon that has been treated such that the excited electrons will gather on one side. This creates a potential difference within the photovoltaic cell such that there is now a positive and negative side, similar to a battery. At this point, the photovoltaic cell has now converted some of the energy from the photons into electrical potential energy. This potential difference can be discharged to transfer the energy for immediate use, or to be stored while the photovoltaic cell continues to collect additional photons.
What is a buffer solution?
A buffer solution is a solution that has a tendency to resist changes in pH. Even when an acid or base is added to the solution. Buffer solutions consist of a mixture of either a weak acid and its conjugate base, or a weak base and its conjugate acid, dissolved in water. When an acid is added, the base present in the solution tends to bind to the H end from the acid, serving to buffer the change in pH and preventing the concentration of H3O end from changing very much. Similarly, when a base is added, the acid in the solution tends to neutralize the base, again serving to buffer the change in pH by preventing the concentration of H3O end from changing significantly.
What is an elimination reaction?
A reaction in which two ligands or substituents are removed from a molecule.
What is cellulose?
Cellulose, see diagram below, is linear polysaccharide poly for many and saccharide means sugar. So cellulose is a chain of sugar molecules. It's an amazing molecule, it's the most abundant organic compound on the planet because it is the main component in plant cell walls. Cellulose is highly crystalline because of the way the sugar molecules are connected and because of the fact that it's made up of a single enantiomer of glucose. Like polypropylene, highly crystalline polymers like cellulose are very strong enough to make trees stand up straight.
Why is heating often used in chemical synthesis?
Heat is often used in chemical synthesis to increase the rate of a reaction. In some cases, heating is also used to effect a phase change. To minimize the environmental impact of a chemical synthesis, it is often optimal to seek reactions that proceed readily at ambient temperatures so that energy input in the form of heating is not necessary.
How does Viagra work?
Viagra, R. Sildenafil, interferes with an enzyme located in the erectile tissue that breaks down a molecule called cGMP, cyclic guanosine monophosphate. Viagra, R, slows down this enzyme, allowing the amount of cGMP to build up. cGMP is responsible for a process known as vasodilation, or widening of the blood vessels in smooth muscle cells. More blood in these vessels means a stronger erection.
What is a substrate?
A molecule that reacts with a reagent, a subjective label as the substrate is also a reagent.
How can metals be plated onto a surface?
Metals can be plated onto surfaces using a technique from electrochemistry called electroplating. Positively charged metal ions dissolved in a solution are attracted to a negatively charged electrode. This electrode gives electrons to the positively charged metal ions, making them into a neutral metal species. The neutral metal is no longer soluble, so it forms a coating on the surface of the electrode.
How many bonds can carbon form?
Carbon has 4 electrons available for bonding with other atoms. When carbon is bonded to 4 other atoms, they are arranged in a tetrahedral geometry. These two simple bonding rules have important consequences, as we'll see in this chapter.
What is a functional group in organic chemistry?
Functional groups are groups of atoms that tend to show similar reactivity in different molecules. Chemists use these groupings to help understand and predict how different molecules react with each other. And they're also used for naming compounds.
How do those new scanners at airports work?
There are 2 main types of these scanners. One uses radio waves to generate a 3-dimensional image of what's underneath a person's clothes, while the other uses low-intensity X-rays to generate a 2-dimensional image. Both of these techniques rely on measuring the radiation that is scattered back off of one's body to generate an image. The purpose of these scanners is to look for basically the same things a security officer would look for in a pat-down. Weapons, explosive devices, or anything else someone is trying to hide.
What is stevia?
Stevia is a commercial name for an artificial sweetener and is also the common name for the plant that it is extracted from. Steviol is the basic structure of this class of sweetener, but when sugar molecules are attached to steviol, making it steviol glycoside, its sweetness skyrockets to hundreds of times that of regular sugar. This sweetener has been in use for centuries in South and Central America and in Japan since the 1970s. In the United States, it's only been available for a few years as a purified compound. Marketed under the name Trivia, raw plant extracts of the stevia plant are not approved for use in the United States.
What are molecular orbitals?
Molecular orbitals are different from atomic orbitals in that they cover several atoms and possibly even a whole molecule. While atomic orbitals originate from a single atom, molecular orbitals are formed from combinations of the atomic orbitals. Because they allow electrons to occupy the space between the atoms in a molecule, they can provide a very useful description of chemical bonds holding atoms together.
What is accuracy?
Accuracy is used to refer to how close a measured value is to the true value of the quantity. This is pretty simple to understand. For example, if the true temperature in the room is 20 degrees Celsius and a thermometer reads 20 degrees Celsius, the measurement is pretty accurate. If the thermometer read 0 degrees Celsius, the measurement is not very accurate.
What is the ideal gas law?
An equation that approximates the properties of gases, commonly written as PV equals nRT, where P equals pressure, V equals volume, N equals number of moles, R equals gas constant, T equals temperature.
What is nylon?
Nylon is a synthetic polymer formed by the condensation of a dicarboxylic acid with a diamine. This reaction forms an amide bond and releases a molecule of water. The term nylon is a generic name for these types of polymers, but one of the common nylons is called nylon 66. The numbers signify the number of carbon atoms in the amine, 6, and the acid, 6, reactants.
Why did Hermann Staudinger, Federal Republic of Germany, win the Nobel Prize for Chemistry?
For his discoveries in the field of macromolecular chemistry. Staudinger was among the first to propose that macromolecules, polymers, are of significant importance and play an important role in chemistry. These views were not initially well received by many members of his field. But he was able to demonstrate experimental proof of the existence of macromolecules. Today the importance of macromolecules is widely recognized in polymer chemistry, biochemistry, and numerous other fields.
What is an atomic orbital?
An equation that describes the probability of finding an electron around a nucleus.
What is volume?
The quantity of space that a substance occupies.
Why did Robert J. Lefkowitz and Brian K. Kobilka, both United States, win the Nobel Prize for Chemistry?
For studies of protein-coupled receptors. Lefkowitz and Kobilka shared this prize for their work studying a class of receptors called G-protein-coupled receptors. These play a role in how cells sense their environment, and especially in how cells respond to medicines, hormones, and other signaling molecules. Lefkowitz had been working in this area since the late 1960s, and Kobilka since the 1980s. But it wasn't until 2011 that they were able to get an image of the receptor at the exact moment that a hormone activates its signaling mechanism. The prize was awarded for their collective body of work elucidating how these receptors function.
What is an isomer?
Molecules with different arrangement of atoms in space, but the same molecular formula.
How can microwaves be used to promote green chemistry?
Microwaves are electromagnetic radiation in the frequency range of 0.3 to 300 GHz. When microwaves are absorbed by many substances, it causes their temperature to increase, thus heating a sample. This is also the same way the microwave in your kitchen heats and cooks food. Microwaves thus offer chemists the opportunity to use heat to promote reactions in cases where conventional heating methods are not possible. This can be useful for promoting reactions under green conditions, such as when we desire to heat the reagents involved in a reaction in the absence of a solvent.
What is aqua regia and what is it used for?
Aqua regia translates to royal water in Latin, and it consists of a mixture of concentrated nitric and hydrochloric acids, typically in a 1:3 ratio, respectively. Since these are both strong acids, aqua regia can be quite dangerous and must be handled with extreme caution. This mixture is capable of dissolving several types of metals and has found many applications in chemistry, including the refinement of very high purity gold.
In what professions is knowledge of biochemistry important?
Biochemistry is important for people interested in careers in human medicine, veterinary medicine, dentistry, pharmacy, and food science, as well as research in almost any physical or biological science and many subfields of engineering as well. While this list isn't all-inclusive, you can see that biochemistry is used by people working in many different areas.
How does baking soda make my cookies better?
Baking soda is sodium bicarbonate, NaHCO3, and is used in cooking as a leavening agent, as in, it helps things to rise. It does this by releasing carbon dioxide, CO2, which it does in the presence of acids, like buttermilk, vinegar, lemon juice, cream of tartar, and so on. The process is much faster at higher temperatures. Once you put your cookies in the oven, the sodium bicarbonate begins to break down, and the carbon dioxide that is released makes tiny little bubbles in the batter. These tiny bubbles get trapped as the cookies bake, making them light and fluffy.
What is thermoplastic?
A type of plastic that hardens when heated and then cooled.
What is a bond strength?
A measure of the energy required to break a chemical bond.
What is a voltmeter?
A device used to measure an amount of electricity.
How do instant noodles cook so fast?
Because they're already cooked. Instant noodles were invented in Japan in the year 1958 by Momofuku Ando, who was working at Nissan Foods. The noodles are flash fried, creating a dry noodle with a very long shelf life that can be prepared in minutes.
What is enthalpy?
For a reaction, the heat absorbed or released is defined as the change in enthalpy.
What molecular properties lead to lower melting points?
Most of the trends we talked about for raising boiling points hold true for melting points for most of the same reasons. There is one major exception, though. The more branched, and therefore compact, a molecule is, the higher its melting point. Because, in general, compact molecules will pack better in a crystal lattice. The better packed a lattice is, the more stable it is, and the more heat energy it takes to break up that lattice and melt the solid.
What is the electromagnetic spectrum?
The electromagnetic spectrum describes the entire range of frequencies, or wavelengths, possible for electromagnetic radiation to have. In principle, the spectrum is practically infinite. Though there are limitations on how high or low of frequencies we can practically achieve and work with. On the high end of the frequency spectrum are usually gamma rays, with frequencies of around 1020 Hz. While on the low end are extremely low frequencies of only a few Hz.
What is binding affinity?
Binding affinity is used to characterize how strongly two molecules interact. Typically this will be a ligand and a receptor site, perhaps in a protein. Another common example would be a drug molecule binding to a receptor site somewhere in the brain. In simple cases where one drug molecule, D, binds to one receptor molecule, R, to form a complex Dr, the binding affinity can be described by the equilibrium constant, Keq equals dr/dr. The binding affinity can be looked at as a measure of how strongly a molecule binds to its receptor site. If a drug has higher affinity for its binding site, less of the drug will be required to achieve a response. Typically, scientists designing pharmaceuticals would like a drug to have a high binding affinity for its receptor so that it can effect a strong response.
How are centrifuges used for nuclear power?
Centrifuges are used to enrich the uranium that is used in nuclear power plants. The two main isotopes of uranium are U-235 and U-238. With U-235 being the isotope used to generate nuclear power via fission processes. Unfortunately, over 99% of naturally occurring uranium is U-238. So a lot of effort has to go into enriching the fraction of U-235 present in a sample. Centrifuges are often used to isotopically enrich a sample of uranium in the U-235 isotope. As described in an earlier question, this is accomplished by spinning a centrifuge tube. And in this case the heavier U-238 isotope is weighed down more, allowing a greater fraction of U-235 to be collected, in the gas phase, from the top of the centrifuge. This process can also be facilitated by heating the bottom of the centrifuge tube, which also helps the U-235 to move toward the top of the tube where it is collected. The process is typically repeated many times before the desired fraction of U-235 is reached. Highly enriched uranium often contains 85% uranium-235 though. So clearly people have gotten pretty good at carrying out the isotopic enrichment process.
Why did Theodore William Richards, United States, win the Nobel Prize for Chemistry?
For his accurate determinations of the atomic weight of a large number of chemical elements. Richards was the first American to receive the Nobel Prize in Chemistry. He and his students accurately measured the atomic weight of 55 different elements and also showed that some crystalline solids can contain gases or other solutes within their lattices, technical term, a fluid.
If chlorophyll gives plants its green color, then what cells give me my skin color?
Melanin is the molecule that is responsible for skin color in humans. It's also what gives your eyes and hair their color. There isn't one single structure of melanin. Rather it refers to a whole class of highly colored molecules that are all derived from the amino acid tyrosine.
What is a peptide?
A polymer of amino acids.
What is the hardest material that has been discovered?
At some point you may have heard that diamond is the hardest material known to humankind. While diamond is extremely hard, there are actually a few materials that are even harder still. Years ago, some synthetically produced nanomaterials were discovered that are even harder than diamonds. Even more recently, two additional naturally occurring materials, both of which are even harder yet, were discovered. These materials are wurtzite boron nitride and a mineral called lensdelite. Wurtzite boron nitride has its atoms arranged in a very similar structure to the arrangement in diamond. But they are just different atoms, boron and nitrogen, rather than carbon. The other material, lensdelite, is actually also made from carbon atoms. But these are arranged differently from those of diamond. Lensdelite is also sometimes called hexagonal diamond and can be formed when meteorites, which contain graphite, hit the Earth at very high speeds. Wurtzite boron nitride is produced naturally at high temperatures and pressures during volcanic eruptions. To date, there are only small amounts of either of these materials that have ever been found or synthesized.
Do all isotopes of an element decay at the same rate?
No, actually each isotope decays at a unique rate. The most radioactive isotopes are those isotopes which decay most quickly. There are some elements, especially the heaviest ones, that don't have any truly stable isotopes. And these can only be synthesized for fleeting amounts of time in laboratory settings.
What is a significant figure?
A digit in a number that is known with some amount of accuracy.
What is a stereoisomer?
Molecules that differ only in the spatial arrangement of their atoms.
What is the DNA?
An acronym for deoxyribonucleic acid, which is the biomolecule that stores genetic information in organisms.